The original title of the presentation was How to Not Fail with React Native. But actually during the preparation I realized that what I thought was really more interesting is the things that I wish I knew before I started with React Native. So what's the background? I'm at Prosenc. I live in Vienna. I work for the 25th floor. It's a small company, a small agile company. We build custom specialized web applications regularly, so we are not specialized in native applications. And about so she thinks it might be better without. So once again, can you hear me?
Yes.
Everybody.
Yeah. Let's get rid of that. Yeah, I like that better. Okay, so enough of my so where did it start everything? Half a year ago, we started with developing a native application for a client. The goal was to have some really truly native behavior. So for that reason, we could not, or actually we did not want to use technologies like Ionic or PhoneGap, which is the project itself was agile, so we had 2-week periods, 2-week sprints, and it was the first project with the customer. We were very, very eager to show off, and actually after the first 2 weeks we delivered kind of a basic application. After 3 months, that's what came out. It was for tools application for searching vacancies and for booking. And after just 2 weeks with React Native, with no experience in React Native before, actually we could deliver some a basic application that did have a true search, search results. You could not actually change the search, that was hard coded, but the results were using the public API. It was live data. We had a detailed view of the vacancies with several tabs, but most of the user interface parts were already there, which was good, which was great. But actually, the fact was we just rushed through the development as fast as we could, and well, we never looked what might be there to make our lives easier. So the talk is about what we missed there and what is good to make development. So React Native. How many of you did use React Native already? So, well, quite a couple. Okay. So you probably will be bored now for a couple of slides about what React Native is. So, but I try to rush it through, okay? So basically it's a JavaScript framework. It builds on top of React. It provides your applications with real native rendering for both Android and iOS. It was publicly released 2 years ago on the first React.js conference. It was in production at that point for 1 year. It's built by Facebook. They use it for the Ads Manager application. What's the basic principle of React Native? So although it uses React, the idea is not to share a common code base of your web application with your mobile applications, because that simply does not make any sense, or not enough sense actually, because the concepts of the UI concepts and interaction concepts are quite different in mobile applications than they are on web. So the idea is actually to learn once and apply everywhere. So all those principles that you learn with React, you can apply that because it is React, but it's not web, and you cannot share the code from the web applications. Just a few examples of big applications that use React Native. The first one is the Ads Manager, is completely built in React Native. The Facebook app itself has a small part that is in React Native. It's the events dashboard, Instagram and Airbnb. Actually, I did not look it up. Okay, if they are really completely in partners. But there is an extensive list of popular applications on GitHub, and there are really many of it. So it is production ready. So to say. So how does it work? The short version is while with React you drive the DOM, the browser, with native, you drive native components in your target system. And that's a big difference to stuff like Ionic, because it is not a web view running a web application. Real true native components with native interaction, delivering a frame rate that is pretty convenient. So under the hood, it's in the application. That's a simplified version. Basically, there are two threads. The main thread responsible for the UI, for delivering 60 frames per second for the platform APIs, and then there is a background thread running the JavaScript interpreter that executes your React application. Those two communicate over a kind of a narrow asynchronous bridge. So drawback here is that the data that can be moved across this bridge cannot be too heavy, too much, and this communication cannot take too frequently. But actually, that's the point of the architecture, because this way the main thread can deliver the 60 frames per second and is not being blocked by JavaScript, and is not being blocked by any computation done by your application. So the user interface stays smooth and reactive. Another advantage of that architecture is that you can take the JavaScript part and move it out of the device and let your app be run by the browser while still communicating over WebSockets with a device. So this way you can get the debugging, can use the debugging tools that you are using with the browser, with developing React. Okay, enough of that. So, native components. So what components do we get with React Native? So there's no need to read that. Okay, it's just to show one thing basically, that there is a bunch of components that are shared for both systems. So when you develop an application, you stay mostly in a realm that can be compiled to both platforms. There are only a few components that are specific for a platform, and actually the iOS specific ones, there are many of those are deprecated. That's with the components. By the way, that's also different with a difference to using React where you drag DOM. So there are no components that are known from the web brand. So there is a image and a text, the view instead of a div. The APIs that are available, it's basically the same image. So there are lots of shared APIs and only a few ones that are specific. I'd like to talk about two of those. Those are the animated, the layout animation, especially because there is one thing when you want to animate things from whatever, some sliding or some image moving across the screen, then it might be problematic with this architecture when JavaScript code is asynchronous connected with the UI. So for that, there are those APIs, the animated and layout animation, where you can
you can define changes in a textual way, like an animated value. It's defined, it starts from x goes to y, and you may even define some key steps, and that can be used in the styling or wherever, and the animation itself is done on the native part. So you do not need to care yourself in the cycles whether I move something on or not. The animation is done natively and with 60 frames per second. So that's an important tool for making transitions smooth and responsive. Another thing is, we had that problem when we just hit the board with performance with some high order components. You can always build your own custom native components if you build them. So you have a guide for Objective-C or Swift Java, or just want to connect some native parts into your JavaScript realm. It's pretty easy done, at least on the JavaScript part. I won't show anything about the Objective-C part. So no expertise there. It's not relevant anyway. But that's the simplest possible example of wiring up JavaScript component with a native component. So let's assume there is in your that's for macOS 10. There is for iOS. Sorry, there is a native component called RTC Manager. I copied that from the documentation, by the way. Then to get that into JavaScript, there is a method you can use called require native component, and that will just wire everything up. So whatever results here and is exported, you just use it as a component of the code. The second argument there, by the way, is for declaring properties and stuff. It might get a little bit more complicated when declaring some APIs for that part. So, which leads me to the question, when do I need such an approach to go native? Well, hopefully never. As long as you get your smooth UI, there actually is no need. Well, that might be one situation, but later on that. So, let's say yes, of course, when the UI, when your components go smoothly, well, don't think about it. Just doesn't matter. If they are not smooth, there's still the possibility of move the animations. The native parts use this animated or layered animation. When that works, great. When it doesn't, well, you have to find a solution. All this with some laggy interface. That's what we use for as a shortcut. Of course, when you need some native API that is not provided, there is no way around it, obviously. Okay, well, enough for components. Big difference, styling difference between web and mobile, something that would probably help us if we knew before, because we just went on designing the application in whatever will be easy, and like experience only in web applications. There were some things that we took for granted. Yeah. Good news, everyone. There is no CSS for those that do not like CSS, and there are reasons to avoid CSS. But on the other hand, there are bad news as well. There is no CSS, which makes certain things not easy again. So React Native offers basically a really a basic kind of styling. Okay, so so you can position your things, dimensions, like width, height, margins, padding,
borders, layouting is done mostly via Flexbox. So Facebook offers a native implementation of Flexbox. So all those calculations needed are done again in the UI part. Of course, fonts, colors. But there is not such a thing like floats, like floating stuff. You have to use Flexbox for that. So it's great for some vertical distribution of things, but more in other areas. The Z index works a little bit differently than in the web. Something like a 100% width was added just recently. So it's really a small subset of CSS. And it's always done inline. There is no CSS classes, it's not a text definition somewhere, it's pure JavaScript. Okay, next thing. As you can develop for both platforms, they tend to be different. Some UI concepts are different on Android versus iOS. So there are two possibilities to tackle them. First, at runtime, there is the platform module, just import platform from React Native, and then you can use it to take decisions. Decisions depending on the loss, or just use a selector, which will just probate the object for the platform you are running the code in. The other possibility to distinguish between Android and iOS is to use specific file name extensions. So when you name your components with these suffixes Android.js and iOS.js, you can require them as usual, but the compiler will, or actually the packager will take the one that is needed for the platform to run. Yeah, so some words about tooling. There are a couple of tools available, really helpful. First of all, the command line. So you can get React Native, just an npm package, install it, initiate a new project, and from that project, from inside the project, you can just start the simulator, like run iOS or run Android. It's really quick, and it's really, that's it. Of course, you need to have a simulator, so for iOS, you need to have Xcode. For Android, you need to install some Android machine. Yeah, of course, you can also change the simulator. Talking about simulators, there is one drawback with iOS, of course. To have an iOS simulator, you need Xcode. With Xcode, you need macOS, and to run macOS, you need a Mac. You can run macOS within a virtual machine, but Apple requires you to run this virtual machine on a Mac. Yeah. Oh, by the way, the Android machines consume about 2 GB of space. It's an issue for me. I have a Mac, and it is an issue for me. So I can, yeah, I install just one was sufficient. Good enough. Hot reloading just as well from React. Pretty convenient module component and Redux stuff. Get the module and component reloading out of the box. Just enable it. Yeah. When compiling, you get a couple of tools inside the app. So, for instance, what's fun is the remote JavaScript plugin. That's exactly the thing where you outsource your app into the browser. So where the React application is run by a browser and it drives the simulator, all your or your connected device. So with the browser you actually get only the console, which is great still. Actually you can, you don't need to use the browser, you can for this remote JavaScript debugging, you can use a node server as well. So you can have the command, the terminal for that. But still, that's just the console log. The picture here shows the Redux log, just the Redux middleware. Another thing is the inspector that enables you to, in a very basic way, inspect the component tree, the path actually, and shows some information, but that is at least within the application. So you, as soon as you activate it, you can just have some part of the application, you get any information. Pretty good for the beginning, actually, but it does, well, it can be done better. Also good. There is a React Native debugger that's actually a bundled Chrome with some React debugging extensions that are made to fit React Native, and that's really cool. So here you can really browse through the whole component tree. You can search for components, you can debug your Redux store, and use the console log. For the IDEs, there's not much to say. It's JavaScript code. You can write whatever you want. We used several IDs depending on developer. Actually, Facebook uses Nuclide. I'm not sure if I pronounce it correctly. We didn't try that. It should have great debugging ability. I just read the documentation. And there is dedicated IDE, Deco, the blue one. That's description is an all-in-one development environment specifically designed for React Native. Actually, it brings stuff like drag and drop components into your source code, which is neat, and some property inspector. But still, I didn't try that. I can tell you it sounds great. Talking about Macs, how to do iOS without a Mac? Well, no. That's what the documentation says, React Native documentation. Yeah, it's pretty easy. But there is one way, well, there are several ways if you want to do some stunts. You can build your project on some Mac, get one, and from then on develop on this using some iPhone. There's always a possibility. There are cloud building tools, so you could build your project in the cloud, but well, it sounds pretty useful. But you can use the Expo client. Expo offers, well, the idea behind that is that you have a client already compiled and running on a device, and you just load any React Native application, the JavaScript part of it, inside that, and there you are on the device. That's pretty cool, I think. Actually, a couple of weeks ago, they announced close cooperation with Facebook. So hopefully will be some support in the future. They also bring a nice desktop client where you can just start and initiate a new React Native project. It's pretty convenient. Another thing that they offer is the Sketch. Sketch is kind of a web playground, like code pen or JS field, where you can test your code in the web browser with a live preview. Drag and drop, search for components, drag them in your code, and quickly try that out with the client on your device just by scanning the QR code. So I think this is a great thing. At least for small, you
tests. Okay. So, let's move on. How about the ecosystem? What's there that can be used? Well, of course, as it uses React, you can use, well, I'd like to say everything that you get for React, but actually you can use everything for React that does not use the DOM, for obvious reasons. There is a huge load of node packages, so Reactive components consisting only of JavaScript, conveniently installed, and there are quite lots by now of native components where you have to install or actually enhance your Xcode or Android project, import some modules. But actually, the installation of those is quite easy. Well, it sounds complicated. Okay. So let's do the fun part. The pitfalls. What headaches, the pains that we went through in the past stupidly, and things that would just be good to know for planning. So one thing was this navigation header. That it looks like one would expect it's kind of it's a basic thing, navigation header and some text below it. It took us actually quite some time and pain. We had to implement that by hand for iOS, as far as I remember. It was not that easy at all. A similar thing is that the context menu there was quite a hack. It looks like nothing special. Something we at least expected to, well, at least that it can be found somewhere. Probably some that already. No, let's do that. Another thing, bigger pain was the collapsing header. Also something that, well, like at least it makes sense to get rid of some space when you don't need it. Much better example is like when there's a big header. Yeah, there's a quite lag that is partly due to the recording, but actually there is a lag on the application as well. So I think the lag from the production system it's also it's not that lag, but it's still you can it hurts. It still hurts. That's JavaScript implementation with the animation framework, but well, I don't know. Somehow it freezes up and does not react to the inputs that scrolling went on again. Good news is there are by now at least two components that you can use for that. The first one, the collapsible navbar, is also a high-level, high-order component, so written only in JavaScript. The other one, the React native navigation, brings really a truly native implementation. But I don't know, I just found the two of them. I didn't try them all, but they look really promising. Although the second one is in experimental stage. Model views, that was a surprise. We didn't expect that. We had several places where we needed to display information as a model view, but apparently there is a limitation that there can be only one such. So we ended up implementing a router for the model view that we had to reuse. That was a strange thing. Okay, a couple of words to third-party components. Because as I said, there are lots of things. Actually, the experience that we made half a year ago was a little bit different. So we did find a lot of components, but many of them targeted only one platform. Many of them targeted only one specific problem, so they were not really generic enough. They could not be customized. And yeah, actually, not so many were nice. So, but I think that situation changed. Either it changed or we just did not search good enough. I don't know. Just to show one example, we had that calendar. So we found them. We found, I can't remember exactly, I think like 4 or 5 implementations of a calendar. And there was only one that was customizable or configurable at least halfway to fit our needs. So it was that what we got out, and it still took us quite some time to get it to fit. And actually, we have to disable the landscape view for it to work, because it just it had some issues. One was that it did not resize properly. And yeah, the point is, we had a calendar really quickly at the beginning. It's cool to show it up, but as soon as we needed a little bit more functionality, it became complicated. And in the end, we probably would have been better on implementing the whole thing by ourselves. I think it would not take really more time, but the time was spent. We had to move on. So it still is there. Okay, some fun effects. Performance problem. So, first one we had was that we realized that on an Android device, the app started to perform really, really slow. And it was like it gave us a heart attack. Until we found out there is a dev mode. There is a dev mode that you can just activate, and that slows things down really like hell. And fun fact, that's the first thing in the documentation on the page for performance problems. So, did you forget the dev mode? Yeah, you did. Another thing, especially on Android, is console logs. So as soon as we started logging heavily, that's true, performance down. And sorry. And yeah, there was one thing that was really funny. So at some point, mostly during presentations for the customer, we had issues with the performance that appeared just suddenly out of nowhere. We could not really track that down, where it happened to be that the browser was in the background, and the process, and we were in development mode, so we were running the application from the browser to the simulator, and as soon as the browser gets in the background, or the tab gets in the background, it loses execution priority, and well, that slows you down drastically. So it was erratic behavior. Oh, that's just good. Thank you very much. Okay. Oh yeah, last one was also heavy. So there is a flag for slow animations in Xcode for the iOS simulator. It can be activated with a shortcut, which happened by accident. Suddenly at that point, all animations were really slow. It's like 50 times as slow. Like you could watch it happen. That was funny. So there is a page in the React documentation that lists a lot more situations where you can have
troubles with performance. Those were just fun ones. Okay. So the last but not least pain, upgrade. Upgrading a React Native project brings one problem. So it's not only about upgrading some node packages. Because when initializing a project, you get the code base for your Xcode project or Android. So you get complete code bases for your platforms with project configuration, internal stuff that is stored there. And we're upgrading that can be difficult. So good news, there's a module for that called React Native Git. Just install it, you just run it, and you probably end up with a big fuck up in some configuration files that you didn't know exist. But that probably can be solved in most cases. In good cases, it's just a conflict that can be solved in finite time. The bad cases, you don't even get that far, and the upgrade module just rejects going on. So you end up searching through the issues on GitHub. Our last upgrade had that end where we just stumbled upon a bug in this upgrade. We have to wait until that is fixed. So that's a little bit more to a minefield. Maybe that's not needed. It depends actually on how much you change in your Android or Xcode project. So including some deployment steps. That's the example you were talking about. Might move to changes or yeah. Okay, enough for the pitfalls. Just briefly about deployment. Of course, you can always build your app and just submit it to the Play Store or App Store. But there are tools. And first, there is the Hockey app, which allows you to distribute beta versions. It's really cool. So you just register some beta users, and whenever you have a new version, deploy it over Hockey app. It has nothing to do with the App Store, and the beta users have a client app on their device, which then installs your application. It's really great, and it can be integrated into Fastlane. Fastlane is a complete automation for building, signing, and distribution, deployment. Yeah, that's just something from Fastlane. The point is, with Fastlane you can do the whole process automatically, even if you take screenshots for the App Store. It might take a day or two, but it's really well documented and it works. So that's cool. So deployment now is just press of a button. Actually, then off it goes to Android. Another possibility is to circumvent the stores and just push your JavaScript code. There is no changes in the underlying native code. You actually are not violating Apple restrictions. There are at least 2 providers for that, 2 web services. I didn't read about AdHub, but I guess it's probably it must work quite the same. Code Push is a service from Microsoft where you just register your app. You have, of course, include some modules into your app to have it work. But you register your app, you get it out once, the first time, and then you can just push the recent version of your JavaScript bundle out to all users, which is pretty convenient. Actually, you can get rid of Microsoft because there is
open source implementation of the server itself. It's called Electrode. It's provided by Walmart, so you can host the whole infrastructure by yourself if you want. You can use the cloud. So that's good. Okay. So then I compiled a couple of things that can help when beginning. So a couple of boilerplates. There is Snowflake. It's a starter app. Boiler. It comes with example with for React Native with Redux, React Native router with jest tests and happy server. Pepperoni, more or less the same, similar starter app. Ignite is a CLI, a generator for boilerplates and plugins. So you don't have to copy the file or check out boilerplate, but you can just generate stuff into your project. Personally, I think it's probably a good idea to take some boilerplate because there is a lot of decisions that have to be made, like how do I structure my code, what do I do with differences between the platforms. A couple of things that you probably will think differently about at the end of your project. So why not start with a good idea in the first place? There are some component collections available, quite native-based cross-platform UI components. It also offers a sketch template, so you can use it already in your design process. If you use sketch, JS code, opinionated, node modules, has a section for React Native, and Expo again, the client, the transfer application, offers quite bunch of components as well that can be used by Facebook integration stuff. Yeah, those are the two collections. Yeah, this React Native navigation I did before React Interactable. I found the two of them just a couple of days ago. They look quite nice. Both bring native components, so well, one has to check them out. There is a material UI collection, so if you want to add to the material look and feel on an iPhone, this one should work. Okay, well, that's pretty much it. The React Native docs are really well written before spending an hour on something. And there is that awesome React Native list that consists of pages and pages of links and stuff. So that's like everything React Native can be found there. Okay.